So hello guys, in today's video I'm going to be solving 100 questions on reaction kinetics. So let's start with question number one. To get access to the question, just download it from the description below this video. So this is the question, you download it from the description below this video. So let's start with question number one. It says the unit of reaction rates are. So to get the unit of reaction rate, that's rate of reaction. Rate of reaction is just concentration over time. That's change in concentration over time. So to get the unit, this concentration is in mole per dm cube. So that will be mole per dm cube per time. It can be in seconds, it can be in minutes. So per time. So from the option here, we have mole per dm cube per seconds. That's option E. We have mole per dm cube. Dm cube can also be represented with L in liter. So dm cube is still liter. So mole per dm cube per second. So this is the unit of rate of reaction, and that was option E for question number one. So question number two, they said for the reaction, then they gave the reaction at a particular time, the change in the concentration of bromine oxide to time is 1.5 times 10 raised to power minus 2 mole per dm cube per second. They now said what is minus change in B around, is that asking for the rate of the reaction rate of bromine ion at the same instant. So for you to be able to solve question like this, you should understand that if you are given a equation like this, A plus B given is equal to C plus D. To write their rate, you can just say change in A, that's dA dt is equal to dB dt. But the thing is that this one will be in molar, this B will be in molar, this A will also be in molar. But the thing is that there will be a negative in the reactant side. There will always be a negative here because as the reaction is proceeding, the reactant is going down. So that will be is equal to dc dt is equal to d dt. So you can see here in the product side, we are not going to add minus because as the reaction proceeds, the product is formed. So it's as if the concentration will be increasing. But here, as the reaction proceeds, all these ones, they are decreasing. All this one is increasing. That's why we are putting negative in the reactant side. So this is how you represent it. So to solve that number two question, we are just going to use this talk to do it. So in number two, they gave us this equation, BrO3 minus plus 5Br minus plus 6H plus giving 3Br2 plus 3H2 plus 3H2. So they now said minus changing. They said this minus changing BrO3 minus. That's they said the reaction rate the BrO3 minus dt is equal to 1.5 times 10 raised to power minus 2. Yeah, so they gave us the rate of reaction for this, and they said we should find the rate of reaction for Br minus. So let's just find the formula that connects these two. That will be minus, this is dBrO3 minus BrO3 minus dt is equal to minus dBr minus dt. So they gave us the one for, they gave us the one for negative Br minus. They've already given us the one for all this like this. They gave it as 1.5 times 10 to minus 2. That was 1.5 times 10 raised to power minus 2. They now say we should find the minus change in Br over change in T, which is this. They say we should find this. But you can see in this equation, there's this one has a coefficient, and that's a coefficient of 5. And if you are writing it with the coefficient, you are going to write the coefficient is going to be in the denominator, that will be 1 over 5. If you are writing it with the coefficient, it's going to be 1 over 5. Without the coefficient, just leave it like this. But if you find the coefficient here, it will be 1 over that coefficient. So if it was 3 that was here, it will be 1 over 3. So to find change the BR of dt, we just look for solid of the formula. That will be minus has already cancelled minus. So we already have 1.5 times 10 per minus 2. That will just be the BR minus dt. Then 5 will come here. That will we'll multiply this one by 5. And that will be our answer. And if you multiply this, 5 times 1.5, that will be 7.5. That will be 7.5 times 10 per minus 2. So the answer is B. So let's check question number 3. It's just like question number 2. So let's solve it again. They said for the following reaction, yeah, this is the reaction. This is the question. They said change in P of C6 H14 over change in T. That's the reaction rate. The reaction rate is found to be minus 6.2 times 10 to the minus 3 atmosphere per second. It's still the same thing as concentration per second. And now you should determine the change in P of H2. Change P of H2 over change in T. Now they're asking us to find the reaction rate of H2. So they gave the reaction rate of this. They're asking us to find the reaction rate of H2. So we need to write the formula that connects two of them. So the formula that connects two of them, this is minus d C6H14 over dt is equal to minus here equal in the reactant side is equal to plus 1 over 4 because of this coefficient 4 of the H2 dt. So they're asking us to find the H2 change in T. This is what they're asking us to find here. And here they gave us the change in P, the change in P C6H14. Now they gave us all this stuff to be minus 6.2 times 10 per minus 3. But don't forget that there's also a minus here. So that will be minus of minus 6.2 times 10 raised to power minus 3 is equal to 1 over 4 the H2 over dt. So what we just do is we just multiply this one by 4. So that's the reaction rate for hydrogen will now be plus 6.2 times 10 per minus 3 times 4. Let's do that using a calculator. That will be 6.2 times 10 raised to power minus 3 6 power minus 3 times 4. That will be 2.5 times 10 to the minus 2. So, and that's option C. That's option C. So let's check question number 4. They said for the reaction, they gave the reaction. The reaction rate of hydrogen as change in P of H2 was found to be 2.5 times 10 per minus 2, where change in pH2 is the change in pressure of hydrogen. The answer should determine the reaction rate for C6H14. So they gave us the reaction rate of this one. So you should find the reaction rate of this one. So but they gave us here in pressure, but just know that it's still the same thing. Pressure and concentration in this stuff is still the same thing. So we just find the formula that connect these two. That will be the change in C6H14 minus will be here dt is equal to 1 over 4 the H2 over dt. So they already gave us the value for this. They gave us the value for this. That's change in H2 over dt. They gave us the value for that to be 2.5 times 10 power minus 2. Then also we should find this. That's change in C6H14 over change in T. So what we just do is there's a minus here. Dt is equal to 1 over 4. They already gave us value of this one to be 2.5 times 10 power minus 2. That's times 2.5 times 10 raised to power minus 2. So our final answer of our final answer will be 2.5 times 10 to the minus 2 divided by 4, then multiply by this negative, because this is what we are looking for. We are not looking for negative, we are not looking for the negative of the reaction rate, we are looking for the reaction rate itself. As from the option, they said determine change in P of CCH14 over change in T. They didn't say determine minus, they said determine change in P of C6H14 over change in T. So this is what they are looking for. So after dividing this one by 4, then we multiply by minus, and that will give us 2.5 times 10 raised to power minus 2 divided by 4. And that will give us 6.25 times 10 raised to power minus 3. That will be minus 6.25 times 10 raised to power minus 3. That's atmosphere per second. And from the option, the correct answer is option B. So question number 5, they said for the hypothetical reaction A plus 3B gives 2C. The rate of appearance of C is given by change in C over change in T. Now change the concentration of C over change in T. Now say it may also be expressed as. So they are saying, how can we express the rate of reaction in terms of these stuffs? So if you look at the options, they are comparing the reaction rate of C to the reaction rate of B. But for let's look for the formula that connects all of them together. That will be minus d of change in A dt is equal to minus 1 over 3, because of these three coefficients, of the concentration of B dt is equal to then plus 1 over 2 concentration of C dt. So we want to like express change in C over change in T in terms of these stuffs. So in the options, if you look at the options, just quickly scan the option, you see that there is C and B. These two things, they are comparing together. So let's just clear off A. You don't really need A like that. So this will be, that means you can say if you take 2 up here, that will be minus 2 over 3 dB dt is equal to the C dt. That means we've already expressed the reaction rate of C using the reaction rate of B. So from that you can say our answer is option C. You can see how we did it. You just find the formula that connects the three of them together. Then you look at the one you are supposed to find. Then you cross multiply. You just make this one the subject of formula. Then you get your answer. So from the options, our answer is option C. Minus 2 over 3 change in B over change in T. So you should also know that if there's a coefficient, it will be 1 over that coefficient. And if it's the reactant, it will be minus. If it's the product, it is plus. So question number 6, they said for the overall chemical reaction shown below, which one of the following statements can be rightly assumed? So they said they gave this. The answer from this chemical reaction, which one can be assumed? They said A, the reaction is third order overall. B, the reaction is second order. C, the rate law is, they gave us the rate law. D, the rate law is dash. And E, they said the rate law cannot be determined from the information given. So before I tell you the answer, let me explain this. When they give you a reaction, you cannot find the rate law from the equation. An experiment has to be done before you can get the rate law or even the order of reaction. It's only when it's an hypothetical equation you can use the coefficient. You can just say, if it's an hypothetical equation, you can just say the order of the reaction is this plus this, that's 2 plus 1, then it's third order. Excuse me. But if it is a normal reaction, you cannot get the order of the reaction or the rate law from just an ordinary chemical equation. An experiment has to be done. So from here, the answer is E. The rate law cannot be determined from the information given. So the rate law cannot be determined from here. An experiment has to be done. So the answer is E for number 6. So question number 7. They said the reaction A plus 2B giving products has been found to have the rate law. Then they gave the rate law. R is equal to K, condition of A, condition of B, or in second order, raised power 2. While holding the concentration of A constant, the concentration of B is increased from X to 3X. That means it is tripled. They now said predict by what factor the rate of reaction increases. So this one is easy. What they are trying to say is that when they kept this one constant, when they kept the concentration of A constant, when they tripled that of B, what happened to the rate? What you just need to do is just substitute 3 into the bracket. That will be R is equal to, they kept this one constant, that will be K bracket 3B. So they triple the reaction, 3B raised power squared. That will be R is equal to K 9 9B. That means the reaction is actually multiplied by 9, is increased by a factor of 9. So, and it's even sensible because from a second order reaction, if you double a second order reaction, it will be 2 raised power 2. If you triple it, it will be 3 raised to power 2. If you multiply it by 6, it will be 6 raised to power 2. So the reaction rate has increased by 3 raised to power 2, that's 9. So the answer is option C, 9. So question number 8, they said for the hypothetical reaction A plus 3B given 2C, the rate should be expressed as, so the rate can be expressed in any form of this. So the rate can be minus the A over dt equal to, can also be expressed as 1 over 3 minus 1 over 3b, but this one is also in the reactant side. So that's minus 1 over 3 db dt is equal to, this one is plus, so 1 over 2 dc dt. You can see. So they now ask us that the rate should be expressed as, let's check option A, they said the A over dt. Yeah, that's not the correct. They said change in over change in t. That's not correct. It has to be minus change in over change in t. Option B said minus change in c over change in t. It cannot be minus because in the product side. Option C said rate is equal to minus 3 times change in b over change in t. No, it's not minus 3, it's minus 1 over 3 change in b over change in t. Option D says rate is equal to 1 over 2 change in c over change in t. 1 over 2 change in c over change in t. That's the answer. So the answer is option D. Option E said rate is equal to 1 over 3 change in b over change in t. 1 over 3, it has to be minus. But yeah, they didn't put minus. So the answer is option D. So you should know that, you should know that if they say d dx dt, is still change in x, change in t, everything is still the same thing. So that one should not be a problem at all. So our answer is option D for question number 8. So they said the reaction A plus 2B gives product. It has the rate law of R is equal to Ka then B raised power 3. That means this one is the third order, this one is in third order, this one is in the first order. But there's a invisible one here. And I said if the concentration of B is doubled, while that of A is unchanged, by what factor will the rate of reaction increase? So that of B is doubled, that's R is equal to K. They said that of A is unchanged, that means just normal A, we are going to leave it like that. But that of B is doubled, that's 2B raised power 3. Now R is equal to K A, then 2 raised power 3 is 8, that's 8B. Then we can also rewrite it as R is equal to K. We can bring the 8 outside, A will be here and B will be here. We can even bring the 8 like very very outside. Then they said, so the question is by what factor will the rate of reaction increase? The rate of reaction increased by a factor of 8 because 2 raised power 3 is 8 and this one is unchanged. So 2 raised power 3 is 8. So our answer is option D. Number 9 is D. So question number 10. They said the reaction A plus 2B giving products was found to have the rate law of rate R is equal to K A then B raised power 2. Now this one is in second order, this one is in first order. The now said predict by what factor the rate of reaction will increase when the concentration of A is doubled and the concentration of B is also doubled. So that one is easy. Just concentration of A is doubled and that of B is also doubled. That was 2A here and 2B here, all raised to power 2. Then R will K This one is 2a. Then this one will be 4b. This one will be 4b. Then we can just 4 times 2 is 8. Then we can bring the 8 outside. That will be 8. Okay, this one a b. So our answer is 8. The fact the rate of the reaction is increased by a factor of 8. So instead of writing this in the exam mode, you can just quickly manipulate it that this is doubled and this one is second order, that's 2 times 2 4. This one is also double, this one is first order, 2 raised power 1 is 2, 4 times 2 is 8. So you can just do it fast like that instead of just writing these stuff down. So question number 11, they said the reaction A plus 2B given product was found to follow the rate law. R is equal to K raised to power 2B, condition of B. So this A is in second order, this B is in first order, because this one is raised to power 1. So it's first order. The next you should predict by what factor the rate of reaction will increase when the concentration of A is doubled and the concentration of B is tripled. So you can just say, to do it fast, since you already know how to do the normal process, you can just say if this one is doubled, that's 2 raised to power 2 times this one is tripled, 3 raised to power 1. That will be 4 times 3, and that will give you 12. So instead of just writing, so the answer is 12. That's 11 is C. So question number 12, they said appropriate units for a first order rate constant are. So this is testing our knowledge on unit of rate constant. I know to get the formula for unit of rate constant is, the unit of rate constant is molar raised by 1 minus n per time, where this n is the order of reaction. So to get first order, that we'll just substitute 1, because first order is 1, second order is 2, third order is 3, and like that. So first order, that's 1 minus 1, 3 raised to power minus 1. 1 minus 1 is 0, that's m raised to power 0, 3 raised to power minus 1, and m raised to power 0 is 1. So no need to write it. That is per time. So for a first order reaction, the unit is per time. This per time can be per second, per minute, per year, per month, as long as it is time. So from the option, we have molar per second, we have 1 over molar times second, we have 1 over second, that's per second. That's our answer. So option C is number 12 is option C. The answer is option C for number 12. 1 over S. But per time is still 1 over T. And it can be 1 over S, that's per second, it can be per minute. So our answer is option C. So question number 13. They said it takes 42 minutes for the concentration of a reaction in a first order reaction to drop from 0.45 molar to 0.32 molar at 25 degrees Celsius. How long will it take for the reaction to be 90% complete? So to get this, they said it takes 42 minutes. That's time is 42 minutes. And this question is just testing our knowledge on integrated rate law. When we know that the first order reaction, the formula is ln B over B minus X equal to KT. So the time is 42 minutes for the concentration of a reaction, for a reactant in a first order reaction to drop from, that means initial concentration is 0.45. The initial concentration is 0.45. Since it's dropping from 0.45, then it's dropped to the final concentration, B minus X. The final concentration is 0.32 molar. So they said, how long will it take for the reaction to be 90% complete? Before we answer the question, we need to find the value for the rate constant. Then we need to solve for the second scenario. So that's ln 0.45 over 0.32 over 0.32 is equal to K times time. Time is 42 minutes. So let's just find K directly. So just ln of this divided by 42. Let's just make it fast. That's ln 0.45 divided by 0.32 over 42. And that will give 8.12 times 10 to the minus 3. 8.12 times 10 raised to power minus 3 minutes per minute. So that's the rate constant. So we've gotten the rate constant. We just use to solve for the second scenario. So the second scenario now says the second scenario now says how long will it take for the reaction to be 90% complete? So for the reaction to be 90% complete, you just need to, for the reaction to be 90% complete, that means B, the initial concentration was 100% complete. We are solving for scenario 2 now. So for the reaction to be 90% complete, the initial concentration was actually 100%. It's 100%. That's initially before the reaction, everything is 100%. But it was 90% complete. So for it to be 90% complete, you know this one is final concentration. So for something to be 90% complete, that means it's 10% incomplete. That's 100 minus 90. So for it to be 90% complete, it is now means 90% has been used. 90% has been used up. The remaining, which is now 10%, is now the final concentration. So write it as 10%. That's if you are giving the question in percentage. That's when you follow stuff like this. So that's 10%. This one will be 100%, this one will be 10% because this is the final concentration. So they're asking us to look for the time. That will be lean initial concentration, that's 100 over final concentration, b minus x, that's 10, is equal to kt. So we got our k to be this. So let me just clean this up since we use this. So we've gotten our k to be this. That's 8.12 times 10 raised to power minus 3 times time. So let's just solve for time directly. So to get for time, that's ln 10 divided by 8.12 times 10 raised to power minus 3, and that will give you 283 minutes, and that's option E. So our answer is 283.5 minutes. You can just say you can approximate to 284 minutes, and that's option E. So 13 is option E. So question number 14. You said the following initial rates. They give us this experiment. They've done the experiment, so they give us the values. And now say which of this is the rate law. So to get questions like this now, yeah, this is the rate law you are going to follow. You are going to follow this pattern. This pattern. Yeah, this is rate constant, this is concentration, and this order of reaction. So to get this, we have to get the order for this. To get the order of NO, we have to keep this one constant, then solve for this one. Let me show what I'm talking about. So let's say we want to find the order of NO. So because this kind of question is just order of reaction we're looking for. Like what NO is raised to power what, Cl2 is raised to power what. That's what they're looking for. So to get the order of reaction for NO, we will look at this one where the rate is constant. So if you look here now, the concentration is constant here. We are looking for NO now. If you look here, the concentration is constant here because this one is 0.5, this one is 0.5. So we now go to the side of NO. Here is 0.5, 1.0, so we'll use this one. If you want to find the order of Cl2, we'll look for the part where this one is constant. That's here and here. So we'll use this one. So let's look for the order of NO. So we'll go to Cl2, it's constant here. So we'll keep this one constant, then we'll look for this. So what we are going to do is we are going to divide the highest with the lowest. That's 1 divided by 0.5. That's 1 divided by 0.5. But before we do that, we also have to divide this rate. We have to divide this rate by this one because we are now considering this part. So that will be 4.79 divided by 1.19. That's 4.79 divided by 1.19. That will be 4. That's 4. 4 is equal to, 1 divided by 0.5, that's 2. 2 raised to power x. So 2 raised to power 4 is equal to 2 raised to power 2, and this one is 2 raised to power x. We are representing the order of reaction to be x because we know that this is the rate law. R is equal to k concentration raised to power n. So this raised to power we are representing with x. This is the concentration 2. That was 1 divided by 0.52. And the rate, this is here 4.79 divided by 1.19. That was 4. So I just using this, I representing with something like this. So I representing the order of reaction with x. So that you for with your law from law of indices, we know that x is equal to 2. That's x is equal to, that means for NO, the order of reaction is 2. So NO must be raised to power 2. And that's between option D and E. So let's find the order of reaction for Cl2. So to find the order of reaction for Cl2, we will just go to the part of NO, the concentration of NO which is constant, like where the concentration of NO is constant. And that's in experiment 2 and 3. This and this, it is constant here and it is changing here. So we just use this one. That's 9.59 divided by 4.79. 9.59 divided by 4.79. That's 2. That's 2 is equal to, then 1 divided by 0.5 is also 2. Then 2 raised to power x, because we want to look for the order. So from here now we know that 2 raised to power 1 is equal to 2 raised to power x. Now is x is equal to 1. Now is the order of reaction for Cl2 is equal to 1. And that's, so the order of reaction for NO is 2. That's NO raised to power 2. And that for Cl2 is 1. So the answer is option D, because NO must be raised to power 2 and Cl2 must be raised to power 1. So to solve questions like this now, let me just go back, let me rephrase. To solve questions like this, if they give you the experiment and they say you should find the rate law, to get the rate law, we are just looking for the order of reaction. We need to know the order of reaction of NO, and we need to know the order of reaction of Cl2. That means what they must be raised to the power of. We need to know their exponents. So to get their exponents, if we want to get their exponents, we just need to compare the rate to the concentration. And let's say we want to get the order of Cl2, we go to the part where NO is constant and Cl2 is changing. And here, this is where NO is constant, so we use this one because it's constant here and it's changing here. And we just divide, just the way you do it, like just divide it from with the biggest, big divided by small. Here 9.59 divided by 4.79, we get it, and 1 divided by 0.5, we get it. So we just use the method I've been using. And to get the order of Cl2, to get the order of NO, you go to the part where Cl2 is constant and NO is changing. Here Cl2 is constant 0.5 0.5 and it is changing here. So you just use this one and just use this one with the rate. So that will be 4.79 divided by 1.19 is equal to 1 divided by 0.5. So that's how you solve questions like this. So the next question is also like this. So let's just go question number 15. So question number 15 now. I don't want to write it on the board, but I hope you are following with the question in the description below. To get access to the question, download it below the description of this video. The link is there. Just use the link to download the questions and you'll see it there. So we are given the experiment just like question number 14. Then they said we should look for the rate law. And I've explained that to get the rate law, what we are going to use to get the rate law is finding the order. If we find the order, then we'll get the rate law. So they gave us the concentration of NO, they gave us the concentration of H2, and they gave us the initial rate. So to find the concentration of NO now, we'll go to the part where H2 is constant and NO is changing. H2 is constant in experiment 1 and 3, and NO is changing there. So the part that NO is changing, that will be 0.042 divided by 0.021. 0.04 divided by 0.021 is the question. No worry, is the question. 0.04 divided by 0.021. That's the bigger one divided by the smaller one. So we'll go to the initial rate. We'll also do the same thing. 5.84 divided by 1.46. 5.84 divided by 1.46. Then don't forget that is the concentration part we are raising to the power of x. So that's 0.042 divided by 0.021. That's 2. That's 2 raised to power x is equal to 5.84 divided by 1.46. That's 4. That's 2 raised to power x is equal to 4. That's 2 raised to power x is equal to 2 raised to power 2. That means x is equal to 2. That means NO raised to power 2. Now let's find that of h2. Let's find out of h2. To get out of h2, to get the order of h2 is just easy. We'll go to the part where the concentration of NO is constant and that of h2 is changing. The where concentration of NO is constant is experiment 1 and 2, and it's changing in h2, so we'll just divide. Would you divide, that's 0.260, like from hydrogen, 0.260 divided by 0.065. Don't forget we are dividing the biggest with the smallest. We are dividing the biggest by the smallest. So the initial rate, that will be is equal to 1.46 over 1.46. You can see they are the same thing here. So let's do that. That's 0.260 divided by 0.065. That's 4. 0.260, that's 4. That's 4 raised power x is equal to 1.46 divided by 1.46, that's 1. So you can say from here that 4, with our law of indices, that anything raised to power 0 is 1. So this can be 4, this 4 raised to power 0. Because 4 raised to power 0 is also equal to 1. That means x is equal to 0. That's to show you that the order of reaction of our H2 is 0 order. And anything raised to power 0 is 1. So our rate law now be R is equal to K NO, from here NO square H2 raised to power 0, which is 1. And that's option B. Rate is equal to K NO square. That's option B. I hope you understand the process. So question number 16 now. It's also the same thing. They gave us the data. They've done the experiment. They gave us the data. They say you should find the rate law for the reaction. So to find the order of S2O8 raised to power 2 minus, you just go to the concentration of I minus where it is constant. It is constant in the experiment 1 and 2. That's 0.06 and 0.06. It is constant there. And it is changing in that side of S2O8 minus. So if it's changing from there, we don't say 0.076 over 0.038. Then we'll do the same thing for the rate. That's 2.8 times 10 per minus 5. 2.8 times 10 per minus 5 over 1.4 times 10 raised per minus 5. This can cancel this. So 0.076 divided by 0.038. 0.076 divided by 0.038. That will be 2. That's 2 raised power x is equal to 2.8 divided by 1.4. That's also 2. That's 2 raised power 1. That's x will now be 1. So for S2O8 minus, so it will be S2O8 minus. That will be in the first order. So let's find that for iodine, as I minus. So to find out of I minus, you just go to the concentration of S2O8 minus where it is constant. That's experiment 2 and 3. So as it's constant in experiment 2 and 3, it is changing yes, in experiment 2 and 3, it is constant for S2O8 minus and it is changing for I minus. So let's do that for I minus. Just the same thing we did here. So that will be big divided by small. That will be 0.06 over 0.03. We are doing big divided by small, so it will be very easy for us to calculate. It was 2.8 times 10 raised to power minus 5 over 1.4 times 10 raised to power minus 5. This raised to power minus 5 can just cancel it out. That will be 0.06 divided by 0.03. That's 2. 2 raised to power x is equal to 2.8 divided by 1.4. That will be also 2. That's 2 raised to power 1. That's x is 1. Now the order of reaction for I minus is also 1. So our rate law can be written as R is equal to K. Let me clean this up. Our rate law, since everything is in first order, that means everything will be raised to power 1. That's S2 O8 minus I minus. That's our rate law. So these are our rate law. Since everything is in first order, and anything raised power 1 is still that stuff. So from that, our answer is option E for question 16. So question number 17, they said at 25 degrees Celsius, the rate constant for the first order, that is the first order reaction, the rate constant is 6.4, blah blah blah. That's 6 point, okay, that's 6.4 times 10 is per minus 3 times 10 is per minus 3 per minute, or minutes per. The answer said if the starting concentration, that's the initial concentration, if the initial concentration, the starting concentration is 0.0314 molar, 0.0314 molar, what concentration will remain? That's the final concentration. We're looking for the final concentration. What concentration will remain after 62 minutes? So to solve question like this, we are just testing our knowledge on integrated rate flow. To solve question like this, just make sure that your time, the unit of your time and the unit of your rate constant must look alike. This one is in minutes, this one is in per minute. Then we leave it like that. Let's say this one is in second. Let's say this one is in per second and this one is in minutes. You have to convert this one to seconds. Or let's say this one is in per minute and this one is seconds. You have to convert this one to minutes. Just make sure the units are the same thing. That is a rhyme. So they're asking us for the final concentration. So from our integrated rate law for first order, notice that is a first order reaction. So that's ln B over B minus X is equal to KT. So that's ln B, that's our initial concentration, that's 0.0314. We are looking for the final concentration. K is this, that's 6.4 times 10 per minus 3 times our time is 62. So to make B minus X is, to make B minus X will be, now let's say, okay, let's do step by step. Here we can just say 0.0314 over B minus X is equal to, to get rid of this lane, you just make the exponent. So you just take the exponential of each side. That will be exponent of 6.4 times 10 per minus 3 times 62. So what are we going to get? Let me use my calculator. That's exponent of 6.4 times 10 raised to power minus 3 times 62. That will be 1.4871. That was 1.4871. Let me write it here. That was 1.4871. That was 0.0314 over B minus X is equal to 1.4871. 1.4871. Then B minus X will now be, that's the final concentration, will now be 0.0314 over 0.0314 over 1.4871. Then our final answer will now be, that's the final concentration, will now be, final concentration is B minus X, that's 0.0314 divided by 1.4871, and that will give us 0.0211. That's 0.0211 molar. And from the options in question number 17, that's option D. So the answer is option D. Question number 18, they said a certain first order reaction A to B is 25% complete in 42 minutes at 25 degrees Celsius. What is the half-life of the reaction? So this is a first order reaction and they are asking us for the half-life. I know for first order reaction, the half-life is ln 2 over K. So, but we don't ln 2 of course is a constant, that's 0.693. But K, we don't know K. But from the other information given, we can find K. So they say it is 25% complete. That means, from what I've thought, you are going to use the integrated rate law. We are using this to find k from the information given. We are using this to find k. So the initial concentration will be 100%, of course, because the initial concentration will be 100% because it has to be 100% from beginning because the initial. So the answer is 25% complete. That means if it's 25% complete, 25% have been used up. What remains, which is the final concentration, is 75%. So that will be 75% in 42 minutes. In 42 minutes. Then find K, just substitute inside. That's lean. B is 100. That's 100 over 75 is equal to K. What's K? K is, we're looking for K, sorry, that's times 42. So just make K the solid of the formula, and that will give us as lean 100 75 42 divided by 42. So that will be 6.85 times 10 to the power minus 3, 6.85 times 10 raised to power minus 3. So we've gotten our K. That means finding half life will now be easy. That's lane 2, that's 0.693 divided by this guy here, 6 points. You can see the board. 6.85 times 10 to the power minus 3. So the half life will now be, that's 0.693 divided by this. That's 0.693 divided by 6.85 times 10 to the minus 3. That will be 101. That's 101. Our answer will be in minutes. 101 minutes, because we've been working in minutes, we didn't convert to seconds. So our answer is going to be in minutes, and the option is in minutes. So if you see that the option is in minutes, just work with minutes like that. You don't need to convert to seconds. You have to work with your options. So the answer is option E, 18. Option E, 101 minutes. So let's quickly do question number 19. We've done something like this before. He said the following initial rate data applied to the reaction. They've done the experiment, so they gave us the data. Then they said we should find the rate law. And I told you to find the rate law, we just need to find the order of each of the reactants, the order of the concentration of each of the reactants. So in this stuff, to find the order of F2 now, to find the order of F2, and to find what is raised to power what, to find the order of F2, find the order of this F2, we'll go to the concentration of Cl2O, and we look for the part where the concentration is constant. And if you look at this information, the concentration is constant at experiments 1 and 3. That's 0.01 and 0.01, and it is changing at F2 at experiments 1 and 3. So let's say for F2 that will be 0.1 big divided by small, 0.1 divided by 0.05 is equal to, we'll apply same thing to the initial rate, the rate. So that was, is 1 times 10 to the minus 3, that was 0.001 mole per dm per second divided by 5 times 10 to the minus 4, that's 0.0005. But this one, we are raising it to the power of x. So 0.1 divided by 0.005, 0.05, that's 2. That's 2 raised to the power x is equal to, yeah, this one will be 0.001 divided by 0.0005, and that's also 2. That's 2 raised to the power 1. That's x is equal to 1. That means F2 has order of 1. So let's find the order of reaction for the concentration of Cl2O. Now to get the one for Cl2O, you go to F2 where the concentration is constant, and that's experiment 1 and 2. For F2, the concentration is constant for F2 at experiment 1 and 2. That's 0.05 and 0.05 is in the data below. You can check the question. To get the question, download it from the link in the description below this video. So at F2 it is constant at experiment 1 and 2. So at Cl2 it is changing. So just divide by big divided by small. That's 0.04 divided by 0.01. Then we'll do the same thing for the rate. That's 2 times 10 to the minus 3. That's 0.002 divided by 0.002. 0.005. This one we are raising the power of x. From this one, we can just say x is 4. That's 4 raised power x is equal to. Then here, 0.002 divided by 0.0005. That's also 4. That's, since it's the same thing, that's 4 raised power 1. That's x is also equal to 1. That Cl2O is also equal to 1. That means the order of reaction for the concentration of Cl2 is also 1. That means our rate law will now be written as, our rate law now written as R is equal to K the F2, which is raised power 1, which is still the same thing, Cl2O. So, and that's option C. So the answer for question number 19 is option C. So question number 20, you're also applying that same principle, just that there's a little twist in question number 20. So to find the order, let's find the order of NO. To find the order of NO, just go to where Cl2 is. Cl2 is constant, that's 1 and 2. That's experiment 1 and 2, that's 0.065, 0.065. And go back to NO. Then since it's constant at Cl2, it's changing at NO. That's 0.66. 0.66 divided by 0.22 is equal to, then you go to the rate, 8.6 divided by 0.96. 8.6 divided by 0.96. This one will give you 3. That's 3 raised power x is equal to 8.6 divided by 0.96 is what? 8.6 divided by 0.96. That will give 9. And that's 3 raised power x is equal to 3 raised power 2. 9 is 3 raised power 2, of course. So that's x is equal to 2. Now the order of reaction of NO is 2. Now what's the order of reaction for Cl2? If you look at this experiment now, there's no part where NO is constant, because experiment 1 is 0.22, 0.6, 0.44. There's no part that is constant. So what are we going to do? We'll just take another, let's go to the concentration of Cl2. Let's use experiment 3 and experiment 2. That will be, or let's say experiment 2 and experiment 3. That will be 0.065 over 0.032 is equal to 8.6 over 1.9 raised power x here. I'm just taking the value. Since nothing is constant, we just take the value of any one. But this is the trick here. So that's 0.065 divided by 0.03. That'll give it 2. Approximately 2. That's 2 raised power x is equal to 8.6 divided by 1.9. That will give 4. That will 4. So 2 raised power x is equal to 4. That's 2 raised power 2 here. 2 raised power 2. That's x raised power 2. But the stuff will not be 2. It will not be x raised power 2. It's not going to be, the order is not going to be 2, because we're now going to multiply this one by what we got here. By what we got here, that will be 4 2. That will be 2. We will multiply it by the order of what we got here, because nothing is changing here. Nothing is changing in the concentration of NO. So what we are going to do is we are going to take the order of this one. We are going to multiply it with what we got here. That will now be 2 times 2 raised to power x is equal to 4. 2 here, 2 here, that's 2. That's 2 raised to power x is equal to 2. That's x is equal to 1. That means for Cl2, the order of reaction will be 1. The order of reaction will be 1. And that's option D. For question number 20, the answer is option D. So why I multiply this one by 2 is because there's nothing changing in the concentration of NO. When I wanted to find the order of NO, we look for what is constant in Cl2. That's experiment 1 and 2, 0.065, 0.065. Then we use the parts of NO, then we found the order. But in NO, there's nothing constant. So what we do is we just multiply it. We multiply the order of NO times how we are solving this one. So when we solve this one, we add 2 raised power x is equal to 4. They will now multiply it by the order of NO, the one that we've gotten before. So our final answer will now be option D. So number 20, the answer is option D. So question number 21, they said a first order reaction has a rate constant of this. Note that they said it's a first order reaction. Now we should know it's a first order reaction. It has a rate constant of 3 times 10 raised to power minus 3. 3 times 10 to power minus 3 per second. The time required for the reaction to be 75% complete is asking us for the time. And I said it is 75% complete. That means the initial concentration is 100%, always 100%. The initial concentration is always 100%. What is the initial? Of course, so it has to be 100%. But the final, just write 100. But the final, they said it is 75% complete. That means 75% has been used. What is remaining? 25% is remaining. That's 100 minus 75, that's 25. So that's 25, that's final concentration. Then so you should find time. Then from our integrated rate law of first order, this is ln b over b minus x is equal to kt. That's ln b is 100, that's 100 over 25. Our k is 3 times 6 minus 3. 3 times 10 raised to power minus 3 times t. So the final answer, that's t. So if you solve for t, that will just be, let me just do it directly. 125 divided by 3 times 10 raised to power minus 3. That will give us 462 seconds. And our answer is option B. So we got 462 seconds. So that's the answer. 462 seconds. So that's the answer to option to number 21. Question 21, option B. 162 seconds. Question number 22. A certain first order reaction, this one is also a first order reaction, is 25% complete in 42 minutes. 42 minutes at 25 degrees Celsius. They said what is its rate constant? It is 25% complete. That means the initial concentration always 100%. The final concentration, since the 25% complete, the remaining will be 75%. That means 75% incomplete. 75% remaining. Now, so what is the rate constant that we are looking for? From the integrated rate law, we know ln b over b minus x, ln b over b minus x is equal to kt. As ln of 100 over 75 is equal to k that we are looking for times 42. So to solve for k, let me use my calculator and solve it directly. That will be ln 175 divided by 42, and that will be 6.85 times 10 to the power minus 3 per minute. That's 6.8 times 10 to the power minus 3 per minute, and that will be option A. So question number 22, the answer is option A. 6.85 times 10 raised to the power minus 3 per minute. So for question number 22, the answer is option A. So question number 23. They said ammonium ion reacts with nitrite ion to yield nitrogen gas and liquid water. The following initial rates of reaction have been measured for the given reactant concentrations. They've done the experiment, they've given the data, so they're asking us to look for the rate law. I've told you for something like this, looking for the rate law, what you need to do is just find the order of reaction of each of the concentration using the data. So to get the order of reaction of NH4 plus ammonium ion, just go to the concentration of NO2 minus. Look for where it is constant. It is constant at experiment 1 and 2. That's 0.02 and 0.02. So you just go back to NH4 plus. Since it's constant and NO2 minus and it's changing here, that it's changing in NH4 plus, that's what we are going to use. So just say that's 0.015. That's big divided by small. 0.015 over 0.01. Then we'll go to the initial rate too. That's the rate. Then we'll do the same thing. Don't say 0.02 divided by 0.03. Since we divided 0.015 over 0.01, that means we are going to divide the rate 0.03 over 0.02. 0.03 over 0.02. the concentration raised by x. That's our rate. That's our order. So 0.015 divided by 0.01, 0.015 divided by 0.01. I'll give you 3 over 2. That's 3 over 2 raised by x is equal to, yeah, 0.03. 0.03 divided by 0.02 is also 3 over 2. And you know this also 3 over 2 raised by 1. That means x is equal to 1. Now the order of reaction for NH4 plus will be 1. Let's just write it somewhere here. NH4 plus, the order of it, NH4 plus, the order will be 1. So that let's look for the order of reaction for the second stuff. Let's look for NO2 minus. Order of reaction for NO2 minus. So order of reaction for NO2 minus. Nothing is changing in NH4 plus. So let's just use any value for NO2 minus. As I've told you, you've done a question like this before. So let's just use experiment 2 and 3. That's 0.02 over 0.01 equal to 0.03 over 0.015. This one be raised by x. Why this one nothing. This one is 0 by s by x. Yeah, this one just be 2 raised by x is equal to 2 2 is equal to 2. 2 raised by x is equal to 2. This one is 1. That means, but we are going to multiply this one with the order that we got here. I'm going to multiply this one with the order that we got here. That will be times 1. That will be 2 raised by x. That's 2 raised by x equal to 2. That means the order will not be x will be 1. Since x is 1, that means the order of reaction is 1. And that will be option B. That will be option B. So question 24. They said appropriate units for a second order rate constant are. That means they're asking us for the unit of rate constant for a second order reaction. And the formula for the unit, it is m raised per 1 minus n then per time. M raised per 1 minus n per time. So they're asking us for second order. I know this n is the order. So since they're asking us for second order, I'll just substitute 2 inside. That'll be m raised per 1 minus 2 per time. That's m raised per minus 1 per time. So looking at the options, this can also be written as 1 all over molar times time. It can also be written as this. It's still the same thing. So looking at it from the option A said molar per second. No. Option B said 1 over molar times second, which is this. 1 over molar times second. The time can be in seconds, can be in minutes, can be in any time frame. So the answer is option B. Option C said 1 over s. No, that's our first order. Option D said 1 over molar square times s. No. So the answer for question number 24 is option B. So question 25. This will be the last question for this section. So if you read this part of this video, make sure you've liked and you subscribed. You can also comment the part you don't understand in this video. Just any part you don't understand or you are finding it difficult to understand, just write it down in the video. Just write the question number in the video. Then I'll go to the comment and I will attend to you. Make sure you write in the comment section. Make sure you like and make sure you share this video. Make sure you subscribe. So question 25, they said the isomerization of cyclopropane to form propane. Then they gave the equation is a first order reaction. This isomerization, that one doesn't concern us. This is the reaction rate, this reaction kinetics we are talking about. So it's just the main information you should pay attention to. So it's a first order reaction, yes, at 760 Kelvin. 15% of the sample of cyclopropane changes to propane in 6.8 minutes. That means 15% is used. That means the initial conc is 100%, right? 15% changes to propane. That means 15% is complete. That 50% changes. Then the one that does not change, that's the final. The 100 minus 15, that will be 85 in 6.8 minutes, right? That's 6.8 minutes. Now, so what is the half-life of cyclopropane at 760 Kelvin? The half-life, no, the half-life for a first order reaction is ln 2 over k. Ln 2 over k. But we don't have k, so we have to find k using this information given. And from the information given, we know we have to use the integrated Ritz law for a first order reaction. That's ln b over b minus x is equal to kt. This thing is in minutes. The time is in minutes, right? Okay, time is in minutes. And since the half-life is also in minutes, now no need to change this one to seconds. You understand? You have to work with your options. So ln b will be 100. That was 100 over b minus x. That was over 85 is equal to k. We're looking for k. That we're looking for times time times 6.8 times 6.8. So k will now be, let's do that quickly, as ln 100 divided by 85 plus 6.8. That will be 0.0239. 0.0239 per minute. So that's the value for k. But we have to find half-life, not k. So half-life will now be ln 2, this is 0.693. Ln 2 0.693 divided by 0.0239. What you got here? So half-life will now be, our half-life will be 0.693 divided by 0.0239, and that will be 28.9 minutes. And from the answer, 28.9 minutes, from the answer is option D, 29 minutes. 28.9 can be approximated to 29 minutes. So 28.9 minutes. So that's our answer. So from the options given, the answer is option D for question number 25. Option D, 29 minutes. So thank you. This is just the first section of the 100 question reaction kinetics. That will be dropping in the next video.